Good afternoon, everyone. Just doing a quick sound check to make sure that everyone can hear me. I think everyone is on mute, but maybe if we just put a message, if you can, I think you should have the ability to type a message. If you can just put on there, if you can hear, that would be great. Okay, I think looking at the messages there, I think we can all hear. So I think we'll probably just start. Okay, so welcome to this webinar, 3D scanning by Solid Print 3D. We're going to have a look specifically at the Peel 3D scanner. Just a little bit about Solid Print 3D first. We've got some info here. So we're part of a Solidworks reseller. We've got over 15,000 engineering-based customers. We tend to work with a variety of brands. So you can see here up on the screen, we're not tied to a particular brand. So you can see we like to think that we give impartial advice on what would suit your needs in terms of 3D printing and 3D scanning. With the scanning, we've got less brands that we work with, but that's just purely out of choice. We've kind of tested most of what's available. We work with Creaform and Peel. Two different price points, I guess. The Creaform stuff tends to be more expensive. The Peel is a sort of entry-level professional 3D scanning system. We have got a backup of, as it says here, 120 plus engineers that we can call on, and many venues across the UK. Okay, so basically anything to do with SolidWorks, 3D printing and 3D scanning and reverse engineering, you can feel free to ask us. We've got a lot of experience in that. Okay, so who am I? My name is Nick Perickley. I've got a background in design engineering. I've worked 12 years or so in SolidWorks technical roles, and specifically 5 years to do with various reverse engineering and 3D scanning within the reseller scene, as well as in industry as well. Tend to like anything to do with engineering. I'm currently restoring a 1956 VW Beetle. So that's basically me. Okay, so let's look at the kit. I'm going to keep this PowerPoint fairly short because obviously we're restricted on time on this web session. We want to be able to see the kit in action, as well as talk about, you know, the various capabilities of the kit, and I'm sure you've got lots of questions as well. So this is just probably, I mean, I'll put these images here on this slide. This is just stuff that I've done personally, probably over the last month or so with this kit. It's quite versatile, as you can probably see there. I've put nearly everything there as objects that you can scan. there are certain things that probably wouldn't be particularly well suited. We'll talk about those more a bit later. But you can see the variety of things here. Automotive is obviously a big part of it. So we had a requirement to scan car interiors. So that's, you can see there, the boot that's being scanned, that came out pretty well. Obviously the exterior of the car that you can see as well, the little Fiat. Any kind of industrial or product design related products, they tend to be a bit curvy and shapely and quite tricky to draw up. So they're ideal candidates for scanning. You can see there, that yellow thing. Anything sculptural, organic shapes are going to be difficult to CAD up. So you can see here that we've got this statue being scanned. Human forms, again, another very organic thing. It's medical sort of devices and human hands, faces, things like that. They come out very well. The only restriction with that is obviously you've got to keep fairly still whilst you're scanning. Yeah, you can see that in the bottom left. Much larger sort of industrial applications. That this particular image you can see here was quite complex installations of pipe work. That this is about 3 meters, the object that you can see there at the bottom in the center. And then finally, on the one on the bottom right there, that's a sort of a marine application. These are either fiberglass or carbon fiber panels, quite large again, and it makes easy work of items like this. Okay, so I hope you just basically see that there's a variety of different objects here. Obviously not limited to these, but hopefully it shows some of the different things we can get into. Okay, so the kit itself, it's handheld. You'd have basic training either via you can either get it by us, or there's a few video tutorials. It's quite user friendly. It's quite easy to use. That's the point of this kit. So it's handheld. It's white light scanning. Depending on which sort of flavor of the kit you go for, you can get different accuracies, but the one I'm going to be using today, the Peel to CAD, we're talking about 0.1 mil accuracy and a 0.5 mil resolution. Okay, if you want to know the difference between the two, you can talk to me at the end. But yeah, it's for a handheld kit, it's pretty accurate. Certainly for the applications, plenty accurate enough for the applications you saw in that previous slide. So you get everything you need when you buy the kit. You've got the all of the hardware. It comes with all of the cables and everything else, as you would probably imagine. And it also comes with the Peel 3D software as well. So a big part of this solution is the software. It really is quite powerful. Okay, it was developed by Careerform, and it still looks very much like their current software. And I think people buy this kit as much for the software as the hardware. There's quite a lot you can do in here, and this is what we're going to be having a look at perhaps during this web session. Okay, so this is the Peel to 3D software. There's, like, when you buy the Peel to 3D, there's two sides to the software. There's the scanning side, so that's the bit of software that you actually scan into and tidy up your scan in. And then there's the sort of, I guess you'd call it the CAD side, where you can prepare things like adding planes, building up surface geometry, taking cross sections, that sort of stuff that you can then put into Solidworks or another CAD package. You're not obviously tied to Solidworks, it's just what we're using here. Okay, so this is the wife's car. This is me scanning this yesterday. We sort of realized that we didn't have a scan of any car panels or anything like that, and you may or may not be automotive based, but as you can probably imagine, by scanning the front end of this car, it sort of demonstrates you know, that it would be suitable for a lot of applications. So we've done a little quick video. This is from yesterday of me scanning this car. I'm going to do a live scan for you in a moment, but we'll just have a quick look at this one, I think, as a starting point. Okay, so I've got a bit of a split screen going on here. So you can see the lower half, I don't work this fast. This is sped up. Just for reference, I've sped this up probably, I think this video in real time is about 15 minutes. Okay, so I've sped it up to under a minute. Just to, you don't want to watch the whole thing. But yeah, it's about 15 minutes worth to scan that front end. And this is what we got out of that scan. So it's a full color scan. You can scan in full color. There's not a lot of color on here because it's a white car and I've put the spray on the lights, but the bare mesh would look like this. Okay, this is a mesh made up of triangles with no color information on it. Okay, and then in the peel to CAD side of things, the CAD part of the software, we can make surface bodies. So this, what you're looking at in orange here, is actually a surface. And you can also do things like create these cross sections. I've just put a number of them, and I think I put about 5 of them in there. It's you choose how many you want and where the spacing. And I've put a plane in here. So the plane, you can select things to, such as a flat surface, to put a plane on. We'll look at all of that stuff in a bit more detail in a minute. But essentially, all of that can then be put out into SolidWorks. So you can see here, I've put the I think we're looking at the mesh there. That is a trimmed down version of the mesh. You can put the surface into your CAD package as well. You can put those cross sections in, and you can use all of that good stuff to produce your CAD data that you're doing all this for. Because obviously, scanning something like a bit of car bodywork, it's really tricky. I mean, I can't draw things like that in SolidWorks without a reference. Anything that involves compound curves, very difficult to measure unless you've got a scan. And I've done dozens of these we call them body bucks. So it's for the classic car sector where you produce the tooling effectively that the metal crafter uses to actually shape the body the old-fashioned way. I've done a number of these over the years, and there's no way I could do it without scanning with something like this peel. So that's what I'd call scanning a fairly large object. You know, we're talking about things that are, let's say, a couple of meters, maybe 3 meters long, I think is the guideline, you know, 3 meters long, so car sized. If you want to scan something bigger, it's not a problem. It will just carry on scanning. But I mean, even if you do it as 2 separate scans, if you had something that was 6 meters long, you could scan it as 2 separate scans. And the software is very clever at stitching the scans together. So especially when you've put targets on the object, like you can probably just about see in that image I've done with the Fiat, I've put targets on there for reference so it knows how to track itself. It can use those targets to align one scan to another. So it's completely accurate if I scan this in 2 halves and then put it together. Okay, so that's scanning big things. What about scanning small things? Okay, so again here, this is one I did a few weeks back. Again, it's just a really horrible shape to have to draw just by taking measurements. Very difficult indeed. So having a scan as a reference can make it so much easier. Okay, so if I just hit play on this one, you can see here, I'll be honest with you, this turntable that I'm using I've just made that myself. There's nothing special about that. That's just a piece of MDF sprayed black with a few of the targets put on there. But you can obviously see how this is working. Same sort of thing. This time on a much smaller scale. Okay, so what I'll probably do is, rather than just showing the video of this, I mean, it's nearly done anyway, I'll put perhaps put this into a mode where I can show my camera and scan something. Right, let's just jump out of there. Okay, so I've fired up the software. Okay, this is the software. This is the Peel 3D software, which, as I said, I mean, some of you, I don't know your backgrounds, you may have used other kit, you may have used Creaform in the past, which is obviously quite a high-end scanning solution. If you've ever used Creaform, this will be very, very familiar to you. It's pretty much the same. Okay, so I'm just going to have a look now at showing my camera. Is that working? Oops. Okay, so that should be my my camera showing now. I'm just trying to see what you can see on here. Let's have a look. Webcam. Okay, it says sharing. Okay, so all I'm going to do, you don't need to see the screen for too long, really. I'll just get it started with this, and then I'll probably put it back onto a screen share. In fact, it should be able to see both at the same time. If I just select here, okay, so I've got my actual screen sharing, but you should be able to see my camera as well. Okay, so I've got that object that we saw there in the video on the turntable. I've got the scanner here. Okay, so this is it. The preparation that I've done prior to this web session is I've basically obviously plugged in the kit. You can see it's tethered. You can see the cable coming out the back of it there. Okay, it's tethered to my laptop, so it's basically plugged into a USB port, and fired up the software. I've calibrated the scanner. Obviously, the scanner comes from the manufacturer calibrated, and depending on which model you get, if you get the Peel to CAD as the one I'm holding, you get a certificate of calibration, which sort of proves the accuracy of the scanner. But then it's always a good idea to calibrate it yourself before using it. It takes about, I think I've got quite used to it now, so it probably takes about 5 seconds to do it. You just use like a board with predetermined targets on. So it takes about 5 seconds, so it's no bother to get it done, and it just ensures that it's sort of optimal calibration. Okay, so I've done that already. I've got my turntable ready. I've got the software turned on, and it should just be a question of, if I just select on here and press go, okay, and sort of just pull the trigger. Okay, so I'm pulling the trigger. Really, the main thing that you need to, I don't need to stay in this position for long, by the way. I can start spinning the turntable. This is why I've got a turntable. Ignore that pop-up. Yeah, so this is why I've got a turntable. It saves me having to walk around the object. You know, if I didn't have it, you can do it without turntable. It just means you have to move around it. Whereas this way, I can just sort of sit still, be nice and lazy in my seat, and just slowly rotate the turntable around. And scanning, this type of scanning works line of sight. So basically, if you can see it, if you let the camera see it, it will pick up the surface. Can you see that bar on the left-hand side of my screen? That's that's the distance indicator. So if I hold my scanner too far away, it will go blue. If I start holding it a bit too close, it's going to go yellow, and then eventually it will go red, and it doesn't like that. You want to keep the camera in the sort of at the optimum distance away from the object. Okay, so you want to keep it green basically, and you go all the way around, and that's probably about it. I mean, I captured that within about 30 seconds, to be honest, but obviously talking about what I'm doing, then that's just a preview. So don't worry if it looks a bit fuzzy, it's just a preview. We then send it to the Peel software, and we should see it sharpen up. Okay, so you can see here, there it is. And people say, well, how do you know you've scanned it? How do you know you finished scanning it? Well, there's nothing clever going on here. I would just look at it, and if there's any bits missing, then we haven't finished. We go back, and you can come back to this as many times as you want. You know, I could literally, if I wanted to, I could save the session up here, turn the computer off, go and have lunch, turn the computer back on, come back after lunch. As long as the dots were still on the object, I could just carry on. Okay, as long as I have the session file, which is the file you're looking at here on the screen, you know, you can just carry on with it. Okay. So typically once I've got this scanned, you know, it depends what you're going to use this for. You might want to tidy up the data a little bit. So for example, we've got a whole bunch of tools here. You can see the toolbar. Essentially, there's some selection tools here. So if I wanted to, we've got this handy selection tool called Connect. So if I just hold down my control key and hit that, and I've just selected a part of the main chunk. So all this is we call it a mesh. It's just basically a bunch of triangles. When you 3D scan, the scanner is picking up lots of points, so millions, in fact, of points, and those points are connected up with lines to form triangles. Okay, so really this is just a bunch of triangles, and Connect just allows me to select all of the triangles that are connected to each other. And this is handy because I can then say, well, let's just invert that selection like that, press delete on my keyboard, continue, and it will delete all of those sort of bits of scatter that you can see there. Okay, so we're now just left with a nice clean sort of mesh of the bit I'm interested in. I'll be honest with you, something like this panel, you know, I don't really need to turn it over and scan the other side. It's a thin-walled object. I'd probably use this, and I'd probably draw this up as a surface, and then in SolidWorks, obviously, you're going to thicken it. Okay, so something like this, there's no real need to turn it over and scan the other side. However, if there was a need to do that, it wouldn't be a problem. Okay, I could just add a scan. There's a button here, add a scan. So then it's a new scan, if you like. Turn this over, scan the other side, and then in the software, it will allow me to stitch the two halves together. This is something that perhaps we can have a look at afterwards. I'm just going to shut this down to stop those pop-ups from coming up. Yeah, so putting two scans together, really not an issue, but not necessary for something like this. Let's say, for example, you want to carry on selecting things here. So I might use a different selection tool. I might decide, well, you know what? I don't need any of this detail here on these lugs, on these feet. I might just want to lose that. You can see how easy it is for me to be able to select that and then delete that little piece there. Maybe I'm just interested in this sort of organic shape at the top here. Okay, can do something similar over this side. There's all kinds of selection tools here. There's even like a brush. You can choose the size of the brush. It sort of gets a bit Photoshop-y at this stage. you know, I can sort of just airbrush out the bit I don't want, like that, kind of delete it. So perhaps just leaving me with the bit I'm interested in. Yeah, and so really that's I won't go too much more detail, but there's a whole bunch of tools here and selection tools that are all to do with scanning, so actually acquiring the data and then trimming it and tidying it up. Once you've done all of that stuff, you can basically go to the other side of the software. You can press the create mesh button here. Just takes a second. A bit of a sounds a bit strange because this is a mesh, but by doing that, it puts those of you that are used to SolidWorks, you probably forgive me for referring to this as a tree. It puts another item in your tree meshes. So these are the things that we're generally working with when we're creating all of those sort of entities and things like that. So you can see you can actually best fit various different sort of shapes, circles, cylinders, planes, cones, that sort of stuff. You can fit all of that stuff onto here. Probably not the best example to do that on because it's quite an organic shape, this thing. But maybe I think we're going to have time in this session to scan a more mechanical type object, and maybe I'll do it on the more mechanical object. So yeah, what else have we got? So again, more cleanup tools for helping you to just tidy up this mesh that you've got here. There's a clean mesh. So although it looks fine to us, but if I wanted to use this for certain operations, like perhaps fitting an auto surface over it, all the hard work there really is in the preparation of the mesh. And even that's not too bad because we've got this clean mesh tool. And if there's any problems with the mesh that are going to affect the surface creation, it will show them here. So if there's any little isolated patches, well, we've already deleted them, or if there's any spikes or self-intersections, anything that's going to cause a problem, it will help us tidy those up. Okay, so we can do that. And once we've done that, we'll then be able to have a look at the auto surface. Okay, really there's no science to this. As you can probably see, a number of controllers with slider bars, which controls the number of patches and control points, which effectively is controlling the accuracy of the surface to the mesh. You can play around with these. I'm just going to see what default gives us and hit preview. This is probably one of the more computationally intensive things that you're asking it to do, and not always needed. I mean, if I was actually going to reverse engineer this panel, the likelihood is I'd probably have to draw up some surfaces with draft angles on and things like that. So I'm really just using this as a reference for me to be able to draw those surfaces in a package like SolidWorks. But then there are times when you might just want to automatically create a surface. An example we sort of did fairly recently was someone needed some bespoke parts for, it was like a one-off body kit that they had, and we were able to sort of do an auto surface, then into that cut a couple of holes and mountings, and then we printed it straight off after that, avoiding all of that complicated CAD work. So it does have its uses. This is just a preview of the patch at this point. You just got to be careful because if you move the sliders around, it can have, obviously this is fit to a tolerance, and you can start losing, it might just go over little holes. I think it's going to probably go over this hole just for now, but that would be fine because I would have already created a reference circle in the right place here, and then I'd make an auto surface, and then I could use that to cut that back out and have a really nice clean crisp edge to the circular cutout that way. So it's actually nice just to sort of fill that in and then cut it out neatly with a proper circle. I think it was going to fill it in. Let's have a look. Okay, yeah, you can see it has. There you go. So what we're looking at now is actually the mesh and the surface on top of each other. If you just want to see one or the other, you would just go to this tree area here and maybe perhaps turn that off, turn the surface on, turn this off. There we go. So there's the surface body, and that can actually be output into sort of fairly generic file types. So you can see here, if I wanted to, I could right click, export that into these type of file types, step file, IGES file, that sort of thing, and it will just come through as a surface body into SolidWorks. You can output the mesh itself. We might want this in SolidWorks, and probably the best format to do this in would be an STL file. Okay, so this mesh, you can do OBJ as well, but both of these are file types that SolidWorks can open up. And to be honest with you, as long as it's not ridiculously large, SolidWorks is going to be able to open it up. I mean, you know, if it's a couple of million points, SolidWorks can generally handle that. You can see how many triangles it's made up from down here. You can see here, this is 121,000. Yeah, so SolidWorks will have no problems with this mesh of this size. Okay. Now, if it was, let's say I'd scanned the Fiat 500 and maybe didn't just do the front, I carried on and did the whole car, that file would typically be something like, I'd expect that to be about maybe 5 million points, something like that. And that's starting to get a little bit too big for SolidWorks. It starts to throw its rattle out the pram at that stage. But that's not a problem, because what we have is some tools in here to help reduce the amount of data in the file. Okay, we've got up here a tool called Decimate. Yeah, so Decimate will take your mesh data, which is made up of a bunch of triangles, and reduce it. So, you know, if we went for, I don't know, something like 50% reduction, estimated triangle count, it's going to be about 60,000, it says, because we've gone 50%. And what we can do is, let's have a look, deviation. You can set a maximum deviation if you want, and you can also preserve boundaries. There's a few options here. I'm just going to go with it like this just for now. I think this is, we're probably going a bit too far on this one, but it's still going to have its integrity, I think, as a sort of a data. Let's just see what that does. Apply. Okay, to be fair, it still looks pretty good. You've got to appreciate the way that this data works. And the reason why that probably doesn't look much different to you, even though it's half the size that it was before, is when you're using your 3D scanner to take data, it's kind of got a uniform spacing between all of the reference points that it's taken. So even on big flat areas like this, it's got lots and lots of little triangles. And we don't really need lots and lots of little triangles to describe what is a relatively flat shape. We need lots of triangles when we start getting into all of these little curvy bits where there's a lot of detail, okay? But we don't need it up here in the flat bits. And the Decimate tool is intelligent enough to have a curvature priority, which basically means it keeps the triangles in the little curvy detailed bits and reduces it in the flat areas, okay? So decimating it before taking it out into another application is obviously, in certain cases, quite important. Although with this file, it wasn't too big anyway. We could have used it as it was. You know, we've got a bunch of other tools here that you might need. I probably wouldn't need it for reverse engineering this. I'd probably just use the mesh as it is and take it into SolidWorks. But again, if we refer back to the Fiat, and I said, you know, you'd be doing perhaps them sort of body buck type constructions like I described, you might want cross sections. Okay, so there's a cross section tool here, and you can create either a single cross section or multiple cross sections. In fact, let's come back to that in a second, because before we do that, it might be an idea if we just aligned this, because we haven't really talked about aligning it. At the moment, and this is how all scanners work, when you start scanning, it's not necessarily going to be in any sensible alignment. Obviously, when you draw something in CAD, you choose where your origin goes and you build up your model around that origin in a nice, sensible fashion, hopefully. When you scan something, it just gets scanned, and I think you can probably see the origin is over here somewhere. So what we would typically do is we would use one of these. We've got a whole bunch of alignment tools here. We'd use an alignment tool, align to origin. Okay. Now with this, it is literally as simple as sort of grabbing these arrows and rings and rotating it into the correct orientation. If I look at, for example, the front view, so I'm looking, well, I say front, I'm looking down the x-axis here. You know, you could perhaps grab this sort of ring and adjust it, maybe go to the side view, something like that, and adjust it. It's probably worth mentioning, it's probably worth mentioning that this part is quite an awkward shape and doesn't really have any sensible sort of flat sides or planar surfaces to it, so it's a bit of a bugger to draw, but it's still helpful to have it in a rough alignment. Okay, so we can sort of move it around like this. When you're happy with the placement of it, you can just press align. Okay. So hopefully, if we go to, for example, one of these views, I'm just using the little triad in the corner here. Okay, I mean, we can be, as you would probably imagine, we can be a lot more accurate than this, but for an initial alignment, maybe we might want to rotate that a little bit more. I know that'll be fine for now, but you can adjust it to your heart's content and get it into the alignment you want. Let's go for a X, Y, no, a YZ maybe. So you can see here, I can either use standard planes to take the cross section from, or I can insert my own plane. It's a bit like your CAD system. And you can see there that that's the cross section. That will be put into your CAD system as a sketch. Or you can go for multiple if you wanted to. So for example, if I wanted to have, let's say, a spacing of, I don't know, 15 mil, and I wanted 5 of them. Just put that in there. There you go. So can you see here, we've got these a bit faint, but you can sort of see them, these 5 sort of look like curves, these green curves. They are my cross section. So we can close this down. All of this stuff, by the way, that I add, whether it be a surface, a plane, a cross section, it all gets added to my tree, and it all gets added under this this mesh 1 sort of area here. Okay, so you can output this information as a step or an IGES file, and then bring it into your CAD system. Okay, so I think I have got something open in SolidWorks. Let's yeah, this is a part that I'm working on. Let's give that a close. And perhaps maybe just have a look at this. So this is SolidWorks 2020. Let's have a little look at that. So all I'm going to do is perhaps that surface, let's have that saved. You can pick one thing if you want and save that out as a file, or multiple items. So maybe we'll just call this part 1 surface. Okay, so this is probably the bit that might take a bit longer. Just there you go, it's done it now, because it is surface data. Okay, but then when you get to the other side, the CAD systems love surface data, so it will be able to process that a lot easier. Whereas the mesh is almost the other way around. If we save out the mesh, let's have that highlighted there. File, export, mesh. I'm going to save that perhaps as just a binary STL, mesh 1 on the desktop. Instant save, but then your CAD systems don't like the mesh data as much. But like I said, this is such a small size, it won't have a problem with it. And then obviously you've got like your cross-sectional information, which you know, if you wanted to save that out, something like probably something like a step file would be fairly sensible with that. So we might call it cross sections. But you can, the point is you can save those out separately, you can save them out together. And then when you get to your CAD package, you've got, I guess, the choice then to import it as you see fit. So for example, if I open and we go to all file types, and that was the mesh. If you want to see what that looks like, perhaps first, there you go. What I tend to do, they're a bit hard to view with all those edges on. See what I mean about a bunch of triangles? It's just that's really what it's made up with. But to see it nice and clearly, I generally just have it on a sort of a shaded view, okay? Like so. There you go. So we can actually use that. There's plenty of tools in SolidWorks now that allow you to work with meshes. I haven't got time in this web session to go through those, but you know, for example, you can take cross sections in SolidWorks with the slicing tool. You can extract shapes. You can open up a 3D sketch and pick points on the mesh. Things like that. Okay, let's bring in perhaps those cross sections. So if you've got a file open already in SolidWorks, you want to bring in another file into the same part, you can just insert it. Just go insert, feature, imported. Choose your file type. So we're going to say step, and I'll get the cross sections in perhaps. There we go, cross sections. And you do the same process for the surface. You bring the surface in the same way. But you can see the cross sections. I always like to mark these out in a certain color, because maybe these sketches here, these cross sections, are just for reference. Okay, so I always used to just put them down as perhaps like a green color, something like that, just to make them completely obvious what they are. And then we can start our hard CADing, or if I'm using the auto surface, I could bring that in the same way. Feature, imported. That was a step as well. Step. So that's just importing the surface. Again, with SolidWorks, you know, it's just doing a translation there. So the first time it sort of opens it up, it's translating the data. Parasolid is SolidWorks' preferred import, but it can work with whatever you throw at it, really. So perhaps if we just hide that graphics body there. The graphics body is the scan, the STL file, and then we've got the surface that's been made. So that's a surface body there. Okay. So back into here. I'm just conscious of time. What we're doing now. We've got a quarter of an hour left. Okay, so might be worth just having a go at something a little bit more mechanical, perhaps, and just having a look at that, and then probably asking some, getting you guys to ask some questions, perhaps. Okay, so let me start a new session. Don't need to save that. Okay, so we're going for a new scan. There's no need to calibrate every time. I mean, unless you're in an environment where the temperature has really changed quite considerably, there'd be absolutely no need to have to recalibrate the machine. So I don't need to do that. You've got some options over here about the sort of resolution that you want to achieve. I'm going to just go for 1 mil. I think that'll be fine. We can go down to 0.5 mil if we want. Just be aware, you can always scan it. It sounds a bit strange, but you can scan at a resolution of 1 mil. And then if you require the extra detail, you can always change the settings later on. Okay, so you can do it after the scan has taken place. It's actually taken in all that data. And really what you're changing there is the resolution of what you're working with on the screen. Okay, but 1 mil is a good compromise. You can sort of see the preview quite well for that, and it will pick up a lot of detail. It's like I said earlier, there is a difference between resolution and accuracy. Okay, so this scanner is accurate to 0.1 of a mil. So that's, you know, if I had a cylinder here that was 20 mil diameter and we scanned it, I'd expect that to be accurate to that accuracy, or 0.1 of that accuracy, you know, 20.1 perhaps. Whereas resolution is, you know, think of DPI when you're looking at photographs. What sort of detail do we need? You know, if I'm scanning something like this object that's very sort of flat and hasn't really got any you know, no text on it or anything that requires high detail, it's absolutely pointless really having the detail, having the resolution turned as high as it can go, because you're not going to see anything different. But if I had lots of very fine writing across the side here, I would then perhaps need to turn the resolution up to be able to get good definition on that text. Okay, so let's move this thing. I've got a heavy old thing here. It's half of a cylinder head off an old Jag. Okay, so one of the questions is, well, do you put the dots on the subject, or do you just have them in the background, like on a board? I'll be honest, it depends on what you're scanning. You know, for example, on the car, you haven't really got any choice. So you'd put the little targets. You can sort of see them here on this board. You'd put them on the car, because you haven't really got you can't. It's not like you can put the car on a board, for example. But with something like this, it's worth considering that this scanner doesn't. It's got a variety of ways that it will actually track and position itself in 3D space. I don't know if you see my screen here, up in the top right, it says positioning parameters. You can use targets only. Targets are these little, I'll show you them here, these little things. They're sort of sticky back, about the size of a, well, just slightly smaller than a 5p coin, and they're sticky. You just sort of put them on. You don't have to just use them once. You can use them you know, a few times. If you get them off whole and you haven't sort of ruined them, you can come back and use them again. So they just stick on. There's no science to them. Just get a sort of a good spacing. You're generally putting them onto flat areas, and they help it to track. You can also use geometry. Okay, on something like this where there's a lot going on, it will be able to use the shape of things to track itself. So it's using the sort of the holes and the irregular surface to help track itself. It sees those shapes and it uses those shapes to help track itself. Whereas something like a car body, where you've got a big expanse of flat bonnet, let's say, there's no shape there at all, which is another reason why you would be putting targets on the car body, because it hasn't got any geometry to help track it, and it would lose itself very quickly. So just be aware that it can use geometry. It can also use texture. Okay, this is like the sort of surface finish of the object. But again, the car body is very smooth, so it's not going to be a fat lot of good there. I generally have it in most cases set to targets in geometry. That way you can put targets on things in the flat areas, and you can actually get away with not putting targets in certain bits. If you remember back to that previous slide, in fact, let me just show you that slide. Where are we? Yeah, this. See this thing here. I said this was about just over 3 meters long. I put targets across the top of this, but this whole area, this whole bit round here, this whole area there, didn't have any targets on. You can probably see there's a lot of geometry, nuts and bolts and welded bits hanging out. It's a very corroded surface, so it's rough and it's got a good texture. A lot of holes in here, and it sort of tracked itself without any targets. But on a car body, you're not going to have that. So, you know, something like this, you might use a bit of both. Obviously, the benefit is something like that previous thing that I scanned. You can have a board set up with targets on, and really, you don't need to put any dots, any targets on the actual object. You can just put it on the turntable. Don't worry about putting dots on it, and just start scanning. So that way, once you've set up a little turntable like this, that's half the work done. You know, you just get in your object, putting it on there and scanning it. So something like this, let me see, let me just check the settings. We've got 1 mil. There's an option to optimize the boundaries. You can scan texture, or you can just have a pure mesh if you want. Perhaps I don't need texture on this one. I just want to capture the mesh. Shutter, another thing that we could talk about. I don't think we've got time, but I've got mine set to auto, so it sorts that out for me. Yeah, and go. Apply the settings. Okay, hold the scanner up. Okay, bit far away, so I move a bit closer. I don't want to spend too long on this because we've only got 5 minutes left, and I am going to take some questions as well. But it was really just to show you here a different type of object. I've got this thing here. It's fairly large. It's a couple of foot long. It's like I said, it's a cylinder head off of an old Jaguar E-Type from the 60s, and you can see I'm just kind of moving this thing around, just moving it around and letting it capture the surface. Trying to keep the bar green. Green is good. Okay. I'm a little bit restricted on space here, just because I'm in my kitchen, the dinner table. And it's when you're scanning, and people, like I said to you already, people say, well, how do you know when you're done? You're going to know as the design engineer what you're going to be doing with that data. Yeah, so it's your job to decide, have I got all the data that I need to do whatever the task is that I'm going to be doing with this? If I'm going to be reverse engineering it, you know, I need to know that I've got enough information there to find out what the valve spacing is, those sorts of things. you might have technical drawings for that sort of stuff anyway. But if you haven't, then you're going to need to know, what is that spacing? What's the inlet port spacing and that sort of thing. So making sure I've got far enough down the sort of barrel of the inlet port to give me that data. I could carry on with this. I'm not going to keep going because we are going to run out of time. But yeah, you can see I've scanned a fair amount of it. If I go into this more detailed view, which we're just going into now, and there's not enough information there, then of course you go back into scan mode and get your scanner out and carry on. There's no science to it. It really is a case of, have I got everything I need to do my CAD? You'd review it, have a look at it. If not, you just carry on scanning, and you do reach a point of diminishing returns. So, as I'm scanning, the first 5 minutes, I'm getting loads of information, and as we go on, the longer it takes, I'm spending more and more time and getting less and less back, if you know what I mean. So yeah, you can see I've started to get the data perhaps that I need. I definitely would need to carry on with this one a bit longer. I've certainly not got enough to work with a lot of what I need. But you can see I'm picking up all of those surfaces. It's things like this that are an absolute nightmare to draw, like the shape of that without any reference data. You can also if I go into if I'm happy with that, and I did go into the CAD side of things, you could start doing things like best fitting a cylinder, for example. If I best fit, these aren't actually cylinders. These will be, or should be. There you go. So can you see how I'm just selecting that thing there, and it's intelligent enough to know that. I just skew the screen. It's intelligent enough to know that all of these triangles are forming what, I haven't even got that side of it, look, we want to get that side as well, really. But it's intelligent enough to know that they are all forming a cylinder, and it's actually best fitting a cylinder, or an axis if I preferred, to those triangle elements. And it's even showing me what the deviation would be. There's a lot of information here about the error distribution. You can see that's pretty tight there. So anything that's green is 0.2. To be fair, you definitely want the whole cylinder to know that you are getting it in the right place. But that's showing how tight a fit that cylinder is on those elements there, those triangles. And if you create that, that will just go into your tree. Can you see here, like it did before, under the entities, and we could collect a load of those and then spit them into SolidWorks as surface cylinders or axes, whatever's easiest for us. Okay, so that was really the last thing I just wanted to show there before we sort of finish. Now, I think that is just about 3 o'clock. So I think what we're going to do is maybe have a look and see if there are any questions. Let me just have a look at this. So I'm fairly new to the GoToWebinar. So here we go, questions. So yeah, I think that's pretty much us bringing this to a close. If you've got any questions, feel free to email them in, or just put them here on this questions or chat board, and we'll get them answered for you. And obviously, if I could just direct you to the Solid Print 3D website, have a look at that. All the information is there. And if you want to have an individual demo booked, if you've got something in mind, you're not sure whether this kit's going to be up to it, and you want us to scan it or do a web session demo, just get in touch with us, and we'll be happy to sort that out for you. Okay, cheers, guys. Thank you very much. Any questions, like I said, let us know, and we'll call it a day there. Cheers. Cheers, Derek. Can it be used for measuring components? Yeah. Yes. Inspection. Yes. I mean, to be honest with you, the company I showed on the slide that was doing the marine components, that is what they were that's one of the reasons that they had the scanner, that they purchased the scanner, was to measure components. So they had they had the CAD, because this thing had already been drawn up in-house and made and manufactured in-house, and then I think their customer wanted to see the deviation between the two things. So they were effectively using it for inspection. Now, there is the question of bringing in the CAD, because obviously, typically, if you're using it for inspection, you're going to have CAD that you've drawn up in another package, and importing that into the Peel 3D software, there are a couple of extra considerations. So what I'd say about that, if you could get in contact with one of our sales guys, they'll be able to talk you through the ins and outs of that. But certainly it is something that's possible to do. You can create what we call deviation maps. Yeah, deviation maps. So you get a color legend at the side of your screen ranging from red to green. You might set your tolerance at 1 mil. Everything that's 1 mil goes green, and you get a color scale of things as they tail off. So yes, it can be used for measuring, it can be used for inspection, but there is a little bit more to it in terms of something to do with the licensing. So it is worth talking to us about wanting to do it, wanting to use it for inspection, and they'll be able to advise you on the pricing side of things for it. Right. Right, sorry, there was those of you that are left. The questions board had sort of minimized. I think it's okay now, so I can see them again. So someone was asking, can it be used for micro moldings? I mean, yeah, moldings in general would be definitely something, depending if it's the finished molding or the tooling that you're scanning. One thing just to consider, if you're scanning objects that are shiny, such as freshly machined bits of steel, if they're too shiny, the scanner doesn't pick them up particularly great. So what you'd have to do is spray. I just use Magnaflux. It's really good. When you saw the scan of the car, the headlights of the car, obviously being made of glass and they're transparent, they wouldn't come out either. So a quick little blast of Magnaflux, just to make them slightly more opaque, enables the scanner to pick it up perfectly. And the reason I'm using Magnaflux is because it wipes off with a cloth. You probably appreciate the missus would not let me spray her car with anything that would be permanent. So yeah, it just wipes off with a cloth. And you can buy special scanning sprays, but they're, as you can probably imagine, a bit more expensive. Magnaflux is about a tenner a can, and I've had the same can now for about 6 months. So yeah, anything glass or shiny, a little spray of that Magnaflux, and away you go, no problems. The micro bit is the bit I'm just questioning here. How small are we talking? If it's too small, you know, I mean, objects, you know, we're sort of going from objects, say this size, up to the size of a, you know, a car 3 meters long in a single scan is fine. If it starts getting too small, you might not, even with the resolution turned up all the way, you might not be able to get the detail you need. So when it comes to micro, I would say the best thing to do is perhaps is to test it. Find typical objects that you want scanned, perhaps come in to us and we'll do you a test scan to check that it's okay. Components, yeah, reverse engineering, 3D scan, obsolete car boots, following the same example, and flat the 3D file to get the 2D shape. Okay, so basically, yeah, great one for that. You would use the pill, perhaps either using the pill software to make an auto surface, if that's good enough, if the scan is clean enough. If not, then you would be using the reference mesh to draw a surface in SolidWorks, and we have a tool in SolidWorks, flatten surface. You only have it in certain levels of SolidWorks. I think it's professional and up. But surface flatten would be able to flatten out that curvy surface into a flat pattern so that you can you know, create a DXF for cutting it, for example. So that's how you do that. Thickness of objects. Thickness of objects. Yeah, again, it just comes down to what is that thickness. You know, if I'm scanning something that's fairly thin, a thin-skinned object, I would add the thickness in the CAD. So if I've done an auto surface, I might then thicken it in SolidWorks. So if I've scanned the outside of an object and I'm going to draw it in SolidWorks, the thickness comes then. If it's too thin, you know, anything less than a few mil, and it might, the scan might make life difficult. It might be more confusing to have those two skins very close to each other. It might be easier to just have one skin and then add the thickness in. What else have we got here? An extra question: when do you consider it is not enough dots on an object to be scanned? Yeah, so the scanner will tell you. You'll be scanning away. Okay, you're scanning away, and you'll get to a certain bit. If it's too flat an area and there's not enough dots, it will stop picking up. You'll see on the screen, it will sort of get a bit jittery and then eventually stop. You'll literally get your box of dots out, whack a couple of dots on. I don't know if you saw it in that video I just did of the car. It actually happened to me on that. I just put a few more dots on, pick the scanner up, and away you go. Okay, it doesn't ruin the scan or anything. It just stops scanning and you add a few more dots on. Medical components such as 10mm depth. Yeah, arrange a trial, I'd say, as you say in the question. 10mm depth should come out fine, I would have thought. 10mm, yeah. You'd probably put this on a slightly higher setting. You might put it on the 0.5 setting, But yeah, certainly arrange the trial and have a look for real. There's no point me guessing with something like this. We want to see that it works for you. Okay, yeah, Neil has put on there that there is a HD scanner coming in late October for items with small detail. There you go. That's even better then. I didn't even know that. Cheers for that, Neil. Okay, cheers, guys. Thank you very much. I think that is all of the questions answered. Nice one. Cheers then, guys. I'm going to log off now as all the questions have been answered. And thank you very much for watching.